I was like perplexed why the name human to the geospatial angle.
We have a lot of obviously formidable competitors in the mapping space.
Imagery goes back to the very beginning of GIS.
If we think about land, I mean, land is a key core to prosperity.
Thank you, Hugo, for speaking with GeoBuiz and Geospatial World.
We spend a lot of effort trying to make sure that the information that we do collect is made publicly available as open.
Hello and welcome to GeoBuiz. We now have a special guest in the studio today, Stuart Minchin, a Chief Environment Geoscience Division, a new division of the GeoScience Australia, I presume. A lot of activities including groundwater, national mapping, earth observation, marine, coastal, and so much on your plate, Stuart, I guess.
Yeah. No, it's a very diverse area, and I'm very privileged to look after such a range of interesting topics, I guess.
I say that the mission statement of GeoScience Australia is about applying geoscience to Australia's most difficult challenges. So how do you see, can you enumerate how this is actually achieved?
Yeah, sure. Well, GeoScience Australia plays a crucial role within the Australian government itself in providing access to geospatial and geoscience knowledge. We do that in a whole range of areas. We, for example, in the energy and minerals domain, we provide resource information to attract investment in our country through energy companies, mineral companies, in terms of the wealth of our land, where we have a large involvement in community safety, dealing with things like monitoring earthquakes, dealing with planning for cyclones and managing of, risk within the community. We look after the operational tsunami warning centre for, along with our Bureau of Meteorology, we manage the Indian Ocean tsunami monitoring system. And in my domain, in particular, the environmental geoscience area, as you mentioned, we look after things like our national Earth observation capability, which for satellite imagery, look after the national mapping program, groundwater, coal seam gas impacts on groundwater, and marine mapping, including, for example, a big involvement at the moment in the search for MH370, the missing airliner in the Indian Ocean.
The strategic priorities of Geoscience Australia are in 6 focus areas. I think the minerals and energy are part of that as well. So which are the other focus areas?
Yeah, look, there are 6 value streams, we call them. Those 6 value streams are really about, it's recognising that what we do in providing information leads on to many values within society, and that they, so managing our resources wealth is one of them. We provide information into, for example, managing our marine jurisdiction, geospatial information, our geography, fundamental geography information, water resources. So the groundwater work is delivering value into managing water resources, managing community safety being another one. So it's really, what that is really about is articulating the role that we play within government, and we see that while we are not necessarily the emergency service agency, for example, yet the fundamental geographical information and the geoscience information that we provide, including Earth observations, is fundamental to delivering that capacity within government. So we are at the beginning of the value chain that is then added to by other government agencies and the private sector in that sense.
As you have rightly pointed out, you are at the beginning of a value chain on the top of which several value-added products and services can be developed within the country. Because you have a variety of spatial information under one umbrella, how easy or how difficult is it a task to coordinate between various mapping activities and also to be able to make it very easy for the government organizations or the general public to access the information?
We spend a lot of effort in trying to make sure that the information that we do collect is made publicly available under open licensing conditions, that we serve not just products and reports, but we serve data, and we do that through open geospatial standards, for example. So we're very heavy users of the Open Geospatial Consortium standards. We have more than 180 different web services that we provide, and this allows other agencies and private sector to access that information in a direct sense, ingest them into their own services and tools. So we have a very active use of our data by third parties to deliver services, and that's deliberate. We're doing that specifically. We can't do everything, and we like to collaborate and partner with others to maximise the use and utility of the information that we collect within government.
One advantage I see vis-a-vis other countries with respect to Australia is that considering a vast amount of spatial data is under one umbrella, it gives very easy to develop a national spatial data infrastructure. Well, it's a huge task in other countries trying to gather all the stakeholders together, create a framework of coordination and also cooperation and collaboration, of course. So how has it been easy in developing a spatial data infrastructure in Australia?
Well, I wouldn't say it's been easy, and in fact, many people looking from the outside at Australia think that we're very well organised and things are going very well, but Australia, when it was federated and made a country out of a number of colonies at the time, actually gave responsibility for much of the management of spatial information to states. So it's actually been a big coordination task for us to bring that data together. It's an ongoing challenge at all times. However, if people have a shared view and vision for what you're trying to achieve, that helps. And the second thing is, I think the fundamental value of spatial and geospatial information is becoming so critical to economic activity within the countries more generally, that we can't afford not to coordinate that and provide clarity and trust and authority in terms of actually having that data organised in a way that the whole of society, regardless of whether you're in one jurisdiction or another, can actually trust and access that information.
One of the strategic directions for 2014-2017 for GeoScience Australia to implement the Foundation Spatial Data Framework. Is it very different from the SDI?
Well, I think that the Foundation Spatial Data Framework is really about defining what are the things that we need to share nationally within a national spatial data infrastructure. So what are the foundation spatial data layers that everyone needs, not just that are not unique to a particular area or jurisdiction, but are actually required truly at a national level for every user of spatial information. And getting agreement on that between our different state jurisdictions took a bit of time, but I think it's been a really good conversation because we now have clarity about what are the things that we need to make available to every user of geospatial information, and what's the value in doing that. The spatial data infrastructures we see as the mechanism to share that at a national level. However, this is really agreeing on what the content is as well.
Has GeoScience Australia set any time frame for realization of this?
Well, this is actually, we are only one party in that conversation. We are, this is being led by our Australian New Zealand Location Information Council, which ANZLIC, and of course we are represented on there. But the themes, the Foundation Spatial themes, were only agreed last year, but there is rapid progress being made in achieving that level of integration.
So you see the Location Information Council objectives and the mandate is much larger than the geospatial component, is it?
Well, it is, but this is one of their key focus topics, I guess, is to get this national level agreement. It's being seen as fundamental. There are other topics. A good example is that we are moving in 2020 to a dynamic datum for Australia. So you know, that has been a key area of discussion at that council. For example, how do we all move from what is a static datum to a dynamic datum, and how regularly would that be updated, and what are the challenges for Australia in that space?
So is this dynamic datum in sync with the GGRF?
Absolutely,
that is being,
yes.
It's kind of now ratified by UN as well.
Yeah, so UN GGIM, the Global Geospatial Information Management Group of experts, proposed a resolution that went up to the UN General Assembly, which has given Australia, you know, the fact that the General Assembly, you know, supported that and made that resolution now gives us confidence that the global geodetic reference frame will continue and be supported in its current form, and that the infrastructure will be there for the future. So that's given us the confidence to move to actually a dynamic datum based on the GGRF for Australia. So you know, we believe we're the first country to move to a fully dynamic datum in that sense.
One of the innovations I have seen from GeoScience Australia recently is the GeoScience Data Cube. Can you tell us more about that?
The Australian GeoScience Data Cube is really an innovative way to structure our Earth observation data in a way that makes it easy to dynamically update mapping information from Earth observation. And effectively what we've done is taken a whole archive of our Earth observation data. We've moved it to a national supercomputer centre. We've got lots of disk space and lots of computing power. And then we have arranged that in a structure that effectively lines up every pixel of that information through time, so that we can actually ask questions about change. So we can look at you know, if we're looking, for example, in Landsat pixels, the history of Landsat, we can look back for 40 years and say, for every 25 metre pixel in Australia, how has that changed over the last 40 years? So over the last 40 years, there have been floods and droughts and, you know, erosion and changes in vegetation. We can measure all of those things objectively through time, and we can do it very rapidly because the data is organised in this way. So this has saved us enormous amounts of time and effort. So things that were just not possible using traditional approaches are now becoming possible. So one example, we've done a complete coverage of Australia for flood footprint, looking at where floods have occurred over the last 27 years in that case. And over that last 27 years, we can tell you where floodwaters have been on every part of the surface of Australia. That product, doing it the way that we used to have to process Earth observation information, would have taken more than 20 years to process, and we can do that in less than 3 hours now. It is a real revolution in the ability to analyse Earth observation information and to bring that in to create maps effectively.
That's actually a phenomenal achievement, and something that every country can and region can emulate.
One of the really important things about that is that in that case we have used, we are now using more than just Landsat data, but we started with Landsat data, and that Landsat data is freely available globally now. Anyone can emulate our approach in that sense with that information. We have the data. Organising it in this way will offer us opportunities to the value from that data, and also to be able to look back at what has happened in the past, which is really powerful.
I see that a lot of forward-looking and very innovative initiatives of GeoScience Australia, and how ready or how evolving or how dynamically GeoScience Australia is evolving to accommodate, to adopt the new technological innovations that are happening in data creation and data updation. Say, for example, in data creation, we have now drones, and we really do not have to get into a field to create a map. Now you have DGPS and satellite imagery to be able to do that. So how dynamically GeoScience Australia is innovating itself, or rather reviving itself to be in tune, to be able to contribute to the economy of the country.
Yeah. Sure. Well, it is a key focus for us. We do have a very large country with a very small workforce in Australia. So often at this stage we don't have a huge effort around drones, for example. We're still primarily reliant on satellites because many areas of Australia are very remote and drones are just not practical even yet. However, we are very actively working with new sources of satellite imagery. So we have new tools, new satellites that have been launched by other countries, the European Copernicus program being a very notable one. We are very much looking forward to using the satellites that have been launched under the Copernicus program and to integrate them into tools like the Data Cube. And likewise, there's been a geostationary satellite put up by the Japanese government called Himawari 8 that provides 10-minute updates of the entire land surface of Australia. So that will be an incredible information source for things like bushfire mapping, for example. We run a national bushfire mapping tool from satellite at the moment, but that only updates 4 times a day because it's using the MODIS sensors on 2 satellites, Aqua and Terra. But with Himawari 8, that will turn into 10-minute updates. So you will have the ability to track in real time the progress of fire through the landscape. So these sort of innovations are really critical to our future work program within GeoScience Australia.
Another approach is to accommodate voluntary geographic information. Is GeoScience Australia looking at ways and means to create a framework to use even crowdsourced data as well?
Yes, we are. I would say that we're not as far down that track as we should be, but we're certainly very interested in utilising and finding ways to assimilate that. If there is one thing I would say about Australia's approach to Earth observation in general, is that we are because we don't have any satellites ourselves, we've become very good at pulling data from multiple sources and using them together to get a better product than you would get from any one source. And that's consistent with our view on crowdsourcing as well. If you're dealing with a product that is solely based on crowdsourcing, you might be quite uncertain about it, right? However, if crowdsourcing is another line of evidence along with different resolution satellite imagery and some in situ information, then it can be greatly beneficial in improving the overall accuracy of your map or your product. We're being only reliant on the official high precision measurements might give you lots of confidence about those points in space, but very little confidence in between. So we view that as a critical source of future information, and we're thinking about ways to incentivise the collection of that.
That's fantastic to know, because the way forward is multi-intelligence and not just dependence on one single source of information.
Absolutely.
Thank you so much, Stuart, for joining us on GeoBuiz.
Okay, thanks.
Once again, Trimble is leading the way in positioning technology with the new Trimble R8S GNSS receiver. An entirely new way to look at receiver possibilities. Simply choose the configuration and features you require today. Then, add features as you need them tomorrow. It's the ultimate in scalability. With this innovative receiver, you tailor your system to your job, to the way you work. Choose the level of configuration that suits your needs. As your requirements change, the Trimble R8S can adapt. You simply add functionality whenever you want it. Each Trimble R8S comes standard with integrated Maxwell 6 chips, Trimble 360 tracking technology, and more. All to keep you productive and expand the reach of your GNSS system. Plus, it offers our exclusive web UI for remote monitoring and the new Trimble DL Android app for GNSS data logging. And the Trimble R8S maximizes productivity by easily integrating with the Trimble S-Series total stations and our innovative V10 imaging rover. For ultimate field efficiency, Combine the Trimble R8S receiver with a Trimble controller and the intuitive Trimble Access Field software. Trust Trimble Business Center to help you edit, process, and adjust your data. It's the kind of solution you have come to expect from Trimble. We've been setting the standard in positioning technology for more than 30 years. See how we're raising the bar again with the Trimble R8S GNSS receiver.
We're here with industry Upbeat, the value of spatial technology for enterprise solutions. Our guests are Stephen Hagen, the Vice President of Oracle, Alex Piliptchak, Director of Schneider Electric, and Geoff Zeiss, who is the editor of Building and Energy, Geospatial Media. Give us quickly a nugget of the point you were trying to make that you wanted people to remember from those presentations. Would you like to start?
Yes, I think a pervasive theme was that the game is changing, that industry is changing, geospatial industry is changing, and that affects other industries. So people have found different ways to apply geospatial technology to convert it from a set of tools and methods that only professionals can access to something that's applicable to everyone's life. We have tasted some of that in consumer world with using tools and mobile phones for navigations, using GPS in our cars, understanding our world a little bit better. But now that's expanding into more advanced users in the industry. That's where we believe that tools change from applications to a platform, something that enables entire business enterprises to access and unlock that power of geospatial information.
Is this something like akin to dropping the pebble in the pond and the waves radiate out and all of a sudden you find there are new things that you can do, new questions you can ask, new industries need to be brought in to solve problems you didn't even think about before?
And I think it's more like a dropping a boulder into a river. It's that big this time around, and many people talk about this being a geospatial revolution. I think that's a second geospatial revolution, and the first one was like dropping a pebble, and not many people have noticed. Now everyone has to notice it. So very good analogy.
Go ahead. Yeah, I was going to add that I think at this point, in a number of industries, if we're going to move forward, you have to have geospatial. And I would say construction is probably the best example. Utilities is another example. In the area of utilities, there's something called smart grid, which just about everybody knows about. If you heard about a smart meter, that's just the first step. But there is so much data now coming from sensors and other types of devices, whether it's weather data or a sensor on a building that can actually detect a beam moving a couple of millimeters, which could be indicative of something much more important happening. You really can't do these things anymore without geospatial technology. So I agree totally with Alex, but I would just push it a first, this is not something that's nice to have and can add some value. This is something where you cannot do certain things without this.
Is it a second wave, or has it been really a constant evolution?
I think it really is the second wave where, what was the initial ripple, if you want to start with that, and that was when people's cell phones, could pull up a map. Then the consumers understood. And it's also that professionals who work in the field, if you're in the utility industry or the building, people now bring out their mobile device to the field and expect to see basically the geospatial information, the maps, but then they can also pull out the drawings that they're dealing with, but then information about it. Where did this come from? Who was working on this project? Et cetera. What were the costs of this? They can do trade-offs in the field and now do it in real time, which is a huge savings. And then, from us, we're down in the lower level platform side, we're getting the pull because of Oracle's, broad database company, which most people are using somewhere. We've classically had this in the back room, financial communities, a variety of other communities, each one using it. But now, from all of these, are saying, look, you've got to have spatial capabilities in your database. So we had to add that. You got to have graph capabilities because we want to plug in our Facebook or wherever we're connecting to people. So we're getting pulled from our customers that you must make this a platform, as he was saying, interoperable and shareable by everybody in all domains. So there's a strong pull, and then maybe this was the experts all knew this, but now everybody knows this. We can't be ignorant anymore because everybody is wise to this and knows how much this could help them.
Is the ROI out there that is a driving force? Hey, you can watch, you can let other people do this, but you need to do it for your shareholders, for customer service, right, and the total integration of the product that you're offering to the public.
I would add that at this point, it's really funny. Most people, when they think of the geospatial, they think of maps traditionally. It's now where geospatial really doesn't mean maps anymore. And in fact, a lot of people don't realize they're using geospatial technology, but every time they go into their cell phone, as Steve said, and enter an address and say, how do I get there? They're using geospatial technology. And it's not a map. They're using other technology. Or if they're looking for all the restaurants that are within 3 miles of their hotel, that's geospatial technology, but there's no map. Sometimes there isn't a map at the end if you're using Google Maps, for example, but in a lot of cases there's technology, there's geospatial technology that people are using that's under the covers and they don't even know they're using it.
It's location, it's location, it's location,
yep,
it's context,
yes,
and content.
Yes. Yeah, one of the really interesting applications is something called geofencing, which means that you can identify when somebody crosses a perimeter, whether it's a perimeter of your store that you want to advertise to, or whether it's a military base, or whether it's utility, and they need to know whether somebody's doing encroaching on their service area, and so on and so forth. But again, that's another example of technology where somebody may not see a map, but their phone has technology in it that is basically geospatial technology.
And it's not necessarily someone crossing a virtual boundary. It could be a weather event, could be a storm. That is where people have ability to react to things in real time. And when we talk about geospatial information, it took this industry, geospatial industry, a while to figure out that, well, it's not only about mapping. And when we analyze things, we don't really care how it would be, what color would be used to present it on the map. We can consume it differently, and we can use that information to optimize how we do things, to do them better, less expensively, make right decisions. And as we learn to make right decisions consistently, we want them to be made tirelessly without an error at a fraction of the cost. We want to automate that. So that's where I think we are on the cusp of moving from mature geospatial technology to industrialized geospatial technology. That's where it becomes sort of invisible, becomes a commodity. That's where I really liked what was said earlier in the sessions today, that the technology is really arriving when it's disappearing. It's disappearing from our side.
I'm going to try and get to that point because we talked about the internet becoming utility and becoming ubiquitous like electricity. You plug it in and it works. The only time you really get upset is when it doesn't work. How much do you want people to really know about geospatial, or does it really make that much difference if they know, but just that it works? At the enterprise level, you want to know about it, you want to make it work because you know what's under the hood. Your customers, maybe not so much.
Well, it depends what industry we are talking about, because we have first-hand experience in trying to apply early GIS, geospatial technology, in areas of, say, electrical design. And it's very hard to sell that value of pure geospatial mapping tooling to an electrical engineer. They want to operate in the world that they know, with a concept that they know. They want to do electrical design. They don't want to build maps. So now geospatial technology is at a point where it can support and fortify the ability to build design that is more consistent, that is more reliable. We have more confidence that what we build will actually work and can be constructed, and it will not fail just because we didn't see something coming. So that is an example of
an institutional outreach tool, geospatial, from the standpoint, as you hear many utilities say, you know, things have changed in the last 4 or 5 years. We now have the ability to do this. We can isolate this. We can have the on-off time reduced tremendously. Where 10 years ago, there were a lot of utilities that got bad names because of poor performance. The lights were out for 3 weeks. The lights were out when it was sunny outside. And there had been movements, you know, to shorten that. And people feel better about that. They don't know why, but they feel better about it.
I'll give you an example. I was talking to a utility. He's basically a field engineer in Upper New York State a few years ago, and he was relaying. He was talking to a colleague about what a problem they'd had last night, where there was an outage in a particular neighborhood, and they went out looking for the transformer. It was dark. They couldn't find the transformer, so they came back the next morning. So that outage was probably at least 12 hours. And part of it was because they had no idea where this transformer was. With where we're getting to with geolocation now and the technology that allows you to find that transformer using, for example, aerial photos, rather than relying on engineering as-built, those engineers could have found that thing in seconds. In fact, they might not even had to go out and find it because there would have been technology that would have identified it automatically as part of the smart grid technology. And that outage could have been seconds. Rather than hours. I mean, that's just a
maybe
practical example.
10, 15 years ago, people might have argued that the cost of improving the infrastructure and implementing some of this was not something they wanted to do just yet. Now, maybe they can't afford not to do some of these things. Is that a fair statement?
Oh, it's very fair. And I'll give you another example with it. Well, the incremental cost of improving the infrastructure is much smaller than it used to be because computers are so cheap, software keeps getting cheap, etc. And again, this is a citizen service one. 45 out of 50 US states use Oracle to map their roads, to manage the roads, because I don't want to use the word mapping. And that's because we can do network graphs. Well, what some of them have done, there's accidents on roads, whether we like it or not. And so the phone call comes in, there's been an accident, a truck went off the road, a big one. He took out part of the railing. See? Well, what kind of railing? And where? And so you can sort of get where it is. What some states have done is they actually drive their roads, and they have these, now the cameras that are clicking, and basically taking pictures of the road every 10 feet, which doesn't cost much, put it in the same database. Then they get the report of the accident. It's at such and such. We know the mileage, where it is. They pull up the database. Okay, it's this kind of fence. When we send the repair crew, usually it was one crew went out, figured out what they needed, came back and got it, and then went back out. Now they know, okay, here's exactly what kind of railing it was. This is where it would have gone out if that's where it was. And the police have the GPS. They know where it is. Load the truck. They go out. They fix it. It's back in operation much more rapidly. Particularly if this is any kind of a dangerous section of road, there's a hill going down, etc. the citizenry is much happier to see that road fixed quickly and at much lower cost.
You could add a layer of cameras out there, perhaps the integration of those from highway department, et cetera. You get a picture of, oh, this is exactly what we need.
That's exactly what you need.
And it's a very nice example from transportation industry.
Yes.
And what we're trying to do in electric utilities, we want to capture that data even earlier upstream. When these structures are being designed and commissioned, we know exactly what materials, what equipment was deployed, what was used there. So when something happens and there is a need to replace or rebuild a part of infrastructure, we can look at that and really come up with a bill of materials and see if it's how they should be sourced, integrate that with work management and enterprise resource management environments, so everything is done easier, faster, and you don't have to second guess as to what do you need to do, what materials, what crews you need to dispatch. So that's how GIS is helping out with efficiencies and improving the time to build or replace or fix something. And we talked about how that improves the perception from the customer base as to reliability of infrastructure, but also even transparency in where we're going to build facilities, and explains to communities what is the impact, what we're building, where we're building substations or where we're building transmission lines. It allows to diffuse and resolve concerns the general public has in regards to how utilities manage their facilities and expand their operations, expand their facilities.
Yeah, I was going to say, you can even carry this further. If you have a major storm coming in and you've got historical data, which is always geospatially based, it's based on where these things happen, and you can relate that to storm patterns, that means the next time that happens, you can have your equipment and the right crews in place so that when that does happen, you'll have whatever you need to replace transformers or whatever type of equipment that goes out. And that's something where you're getting to the point you can say, okay, these are the types of failures we expect. These are the types of crews we need to have in place to solve those things and the type of equipment.
Do you also run into the political reality of how those crews are going to be dispatched, who's going to be paying for it, the predictive issue of, oh, we've had 3 storms in a row right over there. You guys really shouldn't rebuild. However, locally, they're going to rebuild.
One state, I won't mention the name, has really taken this seriously with regard to floods. In other words, they have an entire database of the what was called a digital terrain model, basically the surface of the entire state. And so if a 25-year flood happens someplace, or a 100-year flood, or sea level rise of, say, 50 centimeters happens, they can tell you the economic cost. In other words, the cost to the state economy of what that flood will cost. So that any kind of remedial measures, you can put it in the context of, if I spend $100 million and I prevent the loss of $600 million to the state economy every 5 or 25 or 30 or 100 or 50 years, that is a tremendous value.
Problem I run into with some of the discussion we're having here is that I watch the news too much. And you find that the way decisions are made is not necessarily the way you think they might be made. There's a difference between data and information. There's a difference between information and policy. There's a difference between policy and political will. And while we have these good facts, how do you convince people that this is the way to go, that you need to implement the geospatial in these places to save money, to save lives? How do you really do that?
Part of this is us putting out success stories to the general public. The more information that you can get out, and basically this is another advantage of the social networks nowadays, is as these success stories come out, post, if you realize you're trying to influence a politician, and you have to be careful about this, you make sure enough people post these stories on Facebook or on LinkedIn.
Is that on your Facebook, in Oracle's Facebook?
Oh, I forgot which company I was with. But basically, no, we can't do that. But but basically, you can get the general public to do this because, as you say, if you saw this on the news, they can post information about it. This can be spread in different ways, and I will give you. So I'll shift from construction to a medical example. And it's of the same, it's a similar nature. It's a real thing that happened. Katrina hit New Orleans. A lot of people went from New Orleans to Texas through Houston up into Dallas, etc. Well, a lot of them came over there, were in rough shape. And pretty soon, people were going to emergency rooms, that they didn't know who these people were, but they had various types of ailments. And then, you get into the mix of, like, who are you? Where did you come from? Where are you staying right now? And what are your symptoms? And we get into semantics now. Well, I get a fever, I get a flushed face, I get a temperature, to a medical person, this all means the same thing. And basically, how do you map human syntax down into what's the real fact that it means? And then map it geospatially also. So they were tracking, the potential spreads of diseases among 250,000 people that showed up on a very short notice. And then the emergency rooms all shared this. The University of Texas, basically in Austin, became the master database. They collected information from all emergency rooms through in the entire amount of eastern Texas, collected it to track where there was and where they had to send in extra medical help or track it down in case something really serious was spreading. So then this became known to the general public. So then the pressure from the public goes up to the politicians, which I think is what you're asking about. The general public can push it up that way. We can spread information so easily nowadays.
Yeah, I would say the other thing too is that with geospatial, it's a lot easier than trying to convey the value of a database, like the old databases where we had text and numbers and so on. There's nothing to show, except maybe a number at the end of it, 40. Whereas with geospatial, and especially with 3D, this can be used as a tool and has been used as a tool by politicians. I know for example, the Prime Minister of Singapore wanted to convince the public that there was an important development that was going to happen in the harbor there. Well, he could have shown them, a picture of the building or something like that. He basically showed what you would have seen from an airplane swooping down into Singapore harbor. I mean, and this is all geospatial technology. This is inherently maps, and it's just that it's 3D rather than 2D. And the effect of that is it's much more convincing for people to be able to see a photorealistic rendering of what a development is going to look like, and even be able to walk through it, than to see, some tables of how much revenue is going to be generated by whatever this is.
Yeah, I've seen that in terms of skyscrapers in New York. Apartment buildings are going to be here. We're going to show you what your apartment's going to look like on the 35th floor looking out in that direction.
Yes.
This is exactly it.
Yes.
Well, this was done by using HD cameras being flown by aerostats.
Right.
Now that's being replaced
It's
by
all
drones.
Or it's being generated. It's being generated by what used to be gaming technology, combined with geospatial plus engineering. There was a new highway development in San Francisco, for example, where you could drive this highway before it was built. Right? So all you had was the design specs for it, the geospatial context for it, and you could drive a highway down as you would do in a gaming operation. And it was designed so the public could really see what this highway was going to be like.
Let me ask a general question here about the overall implementation of geospatial at the enterprise level. They all have databases of some kind, but how old is everybody talking to everybody these days? Is everybody plugged into the standards? Are there bridges there where there are differences of semantics? Where do we stand right now?
Well, we're getting a lot better in that it becomes part of the sales story. I sit on the Open Geospatial Consortium Board of Directors, I think, as does Geoff. So that basically, if we know there's standards and we know that, for example, the U.S. government, federal, most European governments require you to be standards compliant. They explicitly say which ones, if you want to sell to them. Well, that forces everybody to be compliant. And you realize once you are, you can do better business with each other. So basically, one, you can sell to the government, but two, you can partner with people a lot easier. So from that sense, it's getting a lot better. Is it perfect? No. And in certain domains, which these guys are more expert at in the BIM domain, we have further to go than in other domains. You know, if you take air traffic control, planes fly in three-dimensional tunnels. You know, that's well described, and it's been described for a while. It's just how is it modeled. The same thing with much of transportation. But, you know, building construction, you know, there's a ways to go yet because there's so much customs.
Yeah, but that is an area where geospatial is absolutely a key technology. The next step in construction is not going to happen. The big thing is building something called building information modeling. It means basically creating a 3D model of the structure you're going to build. But the key is that you want to keep that same model all the way through the construction life cycle, which means from the planning step through to the design step, through to the build and construction, and then through most of the lifetime of that building, which is operate and maintain.
Right, and you add notes to that. You may have the original, but as there are changes in designs, the original stays, and it's all digital, and there's no paper to mess up.
That's right.
Well, and that's where we talk about this long life cycle. It means so many different people get involved, different organizations, different tools. That's where standards and interoperability becomes important to the enterprise. Now, as we start looking further down from enterprise information management into operational controls, that's where we expect standards to become even more strict, because you cannot, the cost of mistake or a fault in operational controls is much higher than in your planning stages or what have you. So,
and that's 70 to 80% of the cost of the building. I mean, the total life cycle of the building is 70 to 80% O&M.
I wanted to jump to a totally different area, and so we can bring back into this, because we're talking about largely Western, you know, really well-developed countries, et cetera, where we're into this level. And I'll take a fairly well-developed country of China. When they're deciding what they want to do next, they fly, you know, over a city, and they map it, and then they say, okay, here's 27 buildings that are not recorded. These are built on the black market. And so if you check against what the city says is supposed to exist versus what really exists, then basically you can find these and then inspect them and say, look, is this thing even safe to live in? And you read in the paper now and then when they discover otherwise. However, if it was, you can then come up to it and say, use a laser, ground-mounted laser, create a model of the entire building, generate the drawings, and turn it into the government and say, okay, we'll pay the fee. Here's your drawings of the building. Then, as you also heard at this conference, 70% of the planet can't get clear title to their land. So if you're dealing with in countries where there are not, basically they can't afford to send out a surveyor, plus there may be resistance from whoever, the local land warlord or whichever. You can fly this with a drone. You can map it and then say, okay, this is what we think the property, this is what's there. From the air. It's there at great detail. You can get it down to about 2 centimeters, which is what they would, and say, here's what it is. Here's what people saying the boundaries should be. Then you can take that model and hand it back to people. And I know the World Bank is doing this, so that's worked to them. They go to the local person who's trying to live on that property or have a little business, say, okay, on this device, because they're not literate. And you've got to remember, you're dealing with people that aren't literate and can't read. But by icons on the device, they can show this is where you are, and this is where your property is, and their faces just glow. Like, this is me? This is where I am? Okay, now this is where you should be, and then it's trying to get through the government how to get clear title. That's only possible because of today's geospatial technologies.
Rwanda built a land registry information system in 1 year for the entire country.
1 year.
1 year, and that was because of the advances in geospatial technology, remote sensing, and so on. Basically, exactly the process that Steve just described. They had remote sensing, they had maps. They said, "Where do you think your boundaries are?" And they talked to all the elders and so on, and drew lines. But within 1 year, they had a land registry information system for an entire country.
How many lawyers were involved?
None. That's the reason it went so quickly.
But millions of people, got taken care of this way. It's a huge amount of.
Let me ask a slightly different question, and that is, they're talking about the implementation, the integration of geospatial in the enterprise. Is there a lot of potential being left on the table because some people, some industries haven't figured it out yet how to make use of it, how to really integrate it in there and solve some problems that they don't know how to solve yet.
Some people believe the insurance industry is the really big opportunity. And it's not that, you know, the insurance company, I mean, I know people in the insurance company, and geospatial is being used there, but when you think of what could be done with geospatial about determining what your probabilities of certain types of accidents or whatever, depending on how close you are to something.
Right.
You know, I mean, it's a huge opportunity.
Did the accident happen? Did it happen here, as it was said?
Yes.
Potential for fraud.
Yeah, absolutely. And it's already, I mean, being used that, for example, if you're doing estimates for building for certain costs on buildings, having accurate air photos is by far the best way to do that, rather than having somebody down below trying to measure from the ground level on a building.
And I'm assuming telecom is moving the same way with the siting of cell sites, a little bit of everything going on that way.
You know, I can probably say that all or most of the industries are susceptible to these same problems, that they are yet to discover the value of geospatial technology and information in their particular market, their particular niche. So that's why, you know, as champions of geospatial world, we have to work with the industry leaders, have to educate, enlighten them, so to speak, as to what is possible, what type of changes they can implement with that.
Is there a word of caution here as we sort of spread out from the mothership to sensors, mobile, et cetera? The further you get away, the harder sometimes protecting the data and information gets a little more difficult. We have to be sure that the data can be protected.
Well, and that is really the nature of things here, is that we create so much data that we can no longer take it to where processing power is. We have to, the only way we can deal with that is in a distributed manner, dealing with data produced and consumed in different localities. So it's a multi-year journey. Industry will not solve security and data management problem over a year or two, but people who started looking into that 5-10 years ago, they're making enough progress to make sure that it's a secure level and secure platforms there for geospatial information in critical infrastructure world, in some areas that may impact health or well-being of workforce or human beings in general.
Take a look at your crystal ball. What do you see down the road in, say, 5 years for geospatial, how it's going to be used? What's different? What's going to be new?
I would say right off that there's a technology which is called laser scanning, which can basically create a 3D model of anything. Could be something in this room, could be a whole building, could be an entire city. Right now it's relatively expensive. I'd say most of those scanners are probably $30,000 and over. You know, 10 years ago or 15 years ago, a digital camera, you know, a good digital camera was $30,000. I expect the same thing with a 3D. You're going to be able to have probably your cell phone, and you'll be able to create a 3D model, take a 3D picture of something rather than a 2D picture of something.
Wow.
Well, I think that in about 10, 20 years from now, there will be more space mapped indoors than outdoors. And I think that we'll be using geospatial technology every day, all day long, without even noticing it.
Yeah. I'll simply endorse their predictions. I'll answer your one caveat on, you were asking for caveats on things here. There's the security issue, and I'll just give you a simple number. The human race or species generates right now about 100 times as much data as we manufacture storage in the computer world, which means the decisions are already being made, but probably not consciously. We're throwing it on the floor. So the question is, if you need a historical context for safety or for whatever, what we all have to get into is, all right, what are we going to save? What's the version? What's changed? And what are we going to all accept? We're going to throw that away. Particularly with the video is the largest culprit. You know, drones flown by the military, that's what I'm most familiar with, but drones in general. We can't keep all that. But some of it you want to keep because you need the history. People have not wrestled with that much. You know, I'm glad people are agreeing with me, but that's in front of our whole industry. And all the sensors, all the Internet of Things, all of this data is coming in, and we can't keep it all. I need to filter it aggregate and decide what can we keep and what do we have to admit we're not going to keep and we're going to throw it away.
In the past, we had paper, and we have archives, national archives full of paper. Well, what are we going to have in the future? I mean, the technology is moving so quickly. 50 years from now, can we read CDs?
Right.
No. It keeps going on and on.
I'll put one reader in storage for you.
Yeah, right. We're archiving certain versions of software, some parts of the government.
Well, and system integrators have kept like at least 2 of the machines that were able to read stuff at the time, so they can go back and do that same thing. Gentlemen, thanks for being here. It's been very spirited, and I'm sure our audience has learned a lot about geospatial on Industry Upbeat. I'm I.J. Hudson. Thanks for being with us.